already know about fractions. I'm going to make a list. So what's one thing you already know?
There can be half, 4, 6, 7, 8.
Alright, so we have some special language, right? We have things like halves. We have things like thirds.
Like they just all have an effect.
We have fourths, which is going to end in that TH, which we're going to see a lot, right? If we get to 6, we again see that TH. So we have a special language for fractions. What else do we know about fractions? Grace, what's one thing that you know? Okay. I think I know what you're talking about. It's not quite the right language, but we know that if we're looking at a number line, here's my number line land, and I have 0 and 1. Fractions are living in between my whole numbers. So in between 0 and 1, there are fractions. In between 1 and 2, there are fractions. In between 2 and 4, they're all in between those whole numbers that we're used to counting with.
Yeah.
Brayden, what else do we know about fractions?
Fractions have numerators and denominators.
Okay, so we have some more language. We have language like a numerator. We have language like a denominator. What else do we know? What does it look like? Have you ever seen a fraction? Sit up. Emma, what do you know about fractions? Okay, so if I have a circle, how would I split that in half? Like this? Yeah.
And then you could,
So this is one model of a fraction. We could have many different models. What else do we know about fractions? Dominic, what else do you know?
you could like do size like that, like make a triangle and a circle also.
Okay. Okay. Ethan?
You can make a slash any way, and also if you are splitting it apart, it has to be equal. It can't be uneven.
That is very true. So fractions do have to be equal. So what that means is I cannot make this cut.
That is
Because whoever gets this little bitty triangle is seriously getting a whole lot less than whoever gets this giant piece.
How are you trying to make?
So if we are doing fractions, every piece, every part, does have to be equal. Sit up. Thank you. So this is not a fraction. I'm going to get rid of that one. The first one that Emma and I did, that one will work because both sides, both parts, are equal. Brayden, what else do you know about fractions?
Fractions will have a number on top, a line in the middle, and a number on the bottom.
Love that.
Or they can have a number on one side and a slash.
Yes, so typically if I'm writing 1/2, I would write my 1 and then a horizontal line and then a 2. That represents 1/2. Now, when I'm typing this, because I can't make, that's called a fraction bar, that line, I use a slash. So you can see it like this. Okay, it can be in red. Sometimes it glitches and goes different colors. So, but yes, both of these are what fractions look like as numbers. Anything else you know about fractions? You guys are on to a good start. A very, very good start. I do want you to write this piece down. Fractions have to be equal. That is probably the most important part of fractions. Each piece has to be equal. fractions are fair. Very fair. Azalea, we're writing that sentence down. We know something else that always has to be equal. What's something else that we know that always has to be equal parts? Eliana? Division always has to have equal parts. Interesting, isn't it?
You can't do 9 divided into 12 groups. That's not going to be
Well, it's not going to be happy. You could do it. You just won't get a whole thing. Unless you chop it up or whatever. But yeah, when we are dividing, I can't have one group with 3 and another group with 7. That's not fair. So we already have learned about equal parts, equal groups. We're going to use that same knowledge that we already know to help us with fractions, because we've already learned that things have to be equal. All right, let's go into it. A fraction is a part of a whole. That should sound very familiar. Yes, please. Go ahead and write that sentence. A fraction is part of a whole. So for instance, if I have a whole pizza, a fraction could be 1 piece. Go ahead and draw a little pizza. We draw a pizza with a circle. Most pizzas are circle. I know some pizzas come square, but we're just going to stay with a circle pizza. And then I've split my pizza. Looks like 8 slices I got. Split it how many slices you want. Just make sure those slices are equal. And then I just want you to color in one of those slices. Here's my slice of barbecue chicken pizza.
Hey, that's my favorite pizza.
What? We're totally like the same person.
How many pizza slices are there?
However many you want. As long as the pizza slices are equal, it does not matter. But I'm going to color in, shade in one of my pizza slices. That 1 piece is now a fraction because it is 1 part of my whole. Go ahead and label your 1 piece as literally the word fraction, because 1 piece is a fraction. The part of my whole thing. Now, that's not all it could look like. We're going to keep going. So it could look like on a number line. We kind of talked about this a second ago when Grace was telling me that it was usually less than 1. It doesn't have to be, but go ahead and draw a number line that goes from 0 to 1. 0 to 1. Now, there aren't any other whole numbers that live between 0 and 1. But there are pieces of a whole number. A fourth lives inside of 0 to 1. It's a part of a whole number.
A half?
We're not quite there. A half would be a part of my whole number. It's not the whole thing, it's only a part. So if I'm looking on a number line, that space between my whole numbers, those are where the fractions live. So let's go ahead and write that. Actually, I'm going to write it right here. Fractions live in the spaces between the whole numbers. So again, that sentence says, fractions lived in the spaces between the whole numbers. I am sure that the majority of you have seen a ruler ever.
I have one.
And we have our whole inches. We see those big ones, those two. And then we have all those little lines in between.
Centimeters.
All those, they are not centimeters.
Inches.
They are still inches. They are just fractions of an inch. They are parts of a whole inch. They're not a whole inch. Look at this little teeny tiny piece. That's not a whole inch.
It's not.
But that is a part of an inch. A really, really tiny part.
And so many of them equal to.
So when I smush all my little parts together, I can get a whole inch. But this one little tiny guy, not a whole inch. It's just a part, aka a fraction.
And it takes 12.
That's where my fractions live on my number line. But guess what? That's not the only place we can see them. We can do visual models, which is what most of us are used to. Maybe. There it is. So this would be a visual area model. Go ahead and draw a square. And then you're going to partition that square into 4 quadrants, 4 boxes.
And color in one.
You can color in one just like I have. Yep. Now, is the whole square colored in? No, just one part, which means that part is a fraction.
So 1/4 of this square.
So this piece right here is a part of the whole, which means it is a fraction. If we could get back to raising our hand to cheer out Fox, that would be great. So again, we're drawing this visual model. It's a rectangle split into 4 parts. And then I colored in 2 random pieces. I will tell you, it doesn't matter where you color them in, as long as you have 2 pieces shaded in. So they could be both on the same side, they could be diagonal like I've got mine,
I like this.
they could be all on the top or all on the bottom.
I like the idea of triangle. I like that diagonal.
Okay, so we've got 2 pieces shaded in. So again, to read a fraction and write a fraction, we have to start by how many parts of something that we have. Well, looking at my model, how many parts did we shade in? Not tricky. Not tricky. Autumn? We shaded in 2 parts. Okay? Now I need to know how many parts did I need to make the whole thing? Well, let's look back at my model. How many equal parts are there in all? Not just the ones I colored, but all of them together. Bailey and Annabella, spend less time coloring. More time thinking about math, please. Lucy, how many parts did I have in all? I had 4. So, the way I'm going to write this is I'm going to write a 2.
At the top.
Please stop doing that. Go ahead and write a 2. Then I'm going to write a fraction bar, which is just a horizontal line. And then I am going to write a 4. So I have a 2, horizontal line, and then a 4. That fraction matches the picture you just drew. Next to that 2, put an arrow. Azalea, next to that 2, put an arrow. Just like in our number 24. Does that 2 right here really mean 2?
No, it means 20.
It means 20
Or 2
or 2/10. It has a special meaning depending on what spot it's in. The same thing in a fraction. Depending on its spot, it has a special meaning. That top spot is called the numerator. Go ahead and write that. Stop coloring, Annabella. So in 2/4, that top number, that 2, is called the numerator. That numerator tells me how many pieces are shaded, or how many pieces I have. Underneath numerator, or to the side of numerator, write AKA. How many pieces I have. So when I look at my drawing, that numerator tells me, oh, you colored in 2 pieces. You must have 2 pieces. That's what that numerator tells me. Adria, please stop messing with water balls. Now we have a digit below the fraction bar. A 4. Draw an arrow next to that 4. That 4 is called a denominator. So our top digit in our number is called the numerator. The bottom digit in our number is called a denominator. That denominator tells us special things. Next to denominator, you're going to write again, AKA. How many pieces make one whole? So that denominator tells me how many pieces make up one whole. Alright, so I see a bar. It is divided up into, looks like, 6 spaces, and 3 of them are colored green. We want to make the fraction. We're going to start with the numerator. Draw my fraction bar. Remember, the numerator tells me how many pieces I have. How many pieces do I have in that top model? How many pieces do I have in that top model? Adria?
There's 3, but up to all.
No. I just want the ones that I have. 3. They should. No, I already said that. Thank you for listening. 3. 3 of them are shaded, so 3 of them are the ones that I have. That's my numerator. What's going to be my denominator? How many pieces make up the whole thing? Whether I have them or not, doesn't matter. Really? 6. Let's read that fraction. 3, 6. There's a TH on that. 3, 6. Tell your neighbor that fraction.
36.
Alright. Let's try this one. Ooh, tricky. Tricky.
Not good. Not me.
I'm going to go ahead and draw my fraction bar. What's the numerator of this fraction going to be? Dominic, the board is on this side of the room, which is where your eyes should be. Miranda, what's the numerator? No, not 4. Probably a little hard to see all the lines from way back there. Azalea, what's my numerator?
6.
6. I have 6 purple rectangles.
And put 12.
Shaded in. What is my denominator? If you don't remember, it's on the board. Autumn? 12. It's how many total pieces I would need to make the whole thing. How do I say that? How do I say that? Tricky. Grace, you want to try? 6 twelfths. We got that TH on the end of twelfths. That's how we know it's a fraction and you're not just saying 6 twelfths. Because 6 twelfths, 12, 24, 36, 48, that would be a lot different than 6 twelfths. Right? Tricky. Tricky, tricky. Ooh. Ooh. Liam, do you see that one?
Oh yeah, that's hard. Which one's the color?
Let's start with the green. We're going to start with the green. What is the fraction of the green? We're going to start with the numerator. How many pieces do I have, Annabella? 2. I have 2 green pieces. How many pieces do I need to make one whole? Eliana? 3. How do I read this? This one's a little bit different. The language is a little bit different, but I bet you have used it before. Arwen? 2/3. What's going to be the fraction of the yellow? I want the whole fraction. What is going to be the fraction of the yellow? Liam, I know you can see this.
1 yellow.
Lucy? 1/3. Very good. Fraction of the green is 2/3. The fraction of the yellow is 1/3. So far, so good, yes?
Yep, it's 2 fractions in 1.
Awesome. Let's see what we got next.
Oh my.
We're not going to go to that today. Alright, we're going to stop here. Go ahead and turn to your math whiteboard, please. You need to have completed 2 independent activities before you can go to partner practice. So if you can complete 2 independent activities, you are more than welcome to move on to partner practice. So I think you can figure that out. Right. Go ahead and make your plan as to what you are going to do, and you may get started.